So I'm going to go through a couple different ways to rewrite exponential equations based on what we did in class. But all of this focuses on us knowing how to write an exponential growth or decay equation using that formula of taking the principal value, taking one adder, subtracting the rate, and raising it to some time unit. And the rate and the time need to have the same unit of time, weeks, days, whatever it happens to be. So we're going to go through 4 separate examples. For the first one, element X is a radioactive isotope with an original mass of 190 grams, so that's talking about a principal value. And the mass decreases by 59% every 2 weeks. So that's telling you your rate is 0.59 and it's decay. So if I wanted to write a function for the mass after 2 weeks, my principal value is 190. I would substitute in 1 minus my rate because it's exponential decay. And for every 2 weeks, that means if t represents the number of weeks, if I left it as just t, that would say I decrease by 59% every week, but that's not the case. So to show that it happens every 2 weeks, I would divide my exponent by 2. Such that when t was equal to 2, that exponent's 1. When t is equal to 4, that exponent's 2. But most of the time, you'll see that simplified to 0.41, showing that every 2 weeks you retain 41% of your original value. So that's one scenario. A lot of the times, though, we have to rewrite formulas that are already given to us. So consider exercise 2. Element X is a radioactive isotope with an original mass of 810 grams, and its mass decreases by 71% every year. The function m of t equals 810 times 0.29 to the power of t can be used to calculate the mass after t years. So what this is saying is they already wrote the function for us. And it shows our yearly rate because our exponent here is the number of years. And what they want us to do is to rewrite it in terms of the weekly growth rate. So because I'm going to have to change the units, I'm going to have to convert this exponent somehow. I want to rewrite the equation so that the function remains equivalent to what we started with. But we want this exponent to represent the number of weeks instead of the number of years. Now remember, there's 52 weeks in a year. So for example, if I have 2 years, that would represent 104 weeks. If I have 3 years, that would represent 156 weeks, and so on and so forth. So that's a multiplication problem. So the number of weeks can be found by taking the number of years and multiplying by 52. That's going to be our new exponent. But we want to keep this equivalent to the equation that we started with. So in order to balance that out, I'm going to raise this inside part to the 1 over 52 power. And the logic behind that is that, remember there was a rule for exponents that said if I have a base and I raise it to a power and raise it to another power, equivalently we can rewrite that as x to the b times c, and we could multiply those powers. Imagine if we did that here, and I multiplied 1 over 52 times 52t, that would just leave me with t, which is exactly what I started with. But we want our exponent to be the number of weeks, so I'm going to leave that as 52t, and then I'm going to type this into my calculator, that 0.29 to the 1 over 52. So that would be m of t equals my principal value times, and I'm going to round this to 3 decimal places. Doesn't tell me how much to, so on a test it would tell you what decimal place to round to. But this equation, since we have a number of weeks in the exponent, is showing us a weekly decay rate. So for example, if we needed to pull that out of the equation, since 1 minus r is what that 0.976 represents, if I solve this equation for r, negative r equals negative 0.024, or r is 0.024, that means our rate is about 2.4% each week that it decreases. So keep that in mind, that if we're trying to convert units, we start by thinking about what expression we want our new exponent to be, and then we raise the inside to something to compensate for that. So there are instances where somebody has already done that, and we need to go back. So that would be exercise 3. The growth of an organism can be modeled by C of t equals 10 times 1.029 to the 24 times t, and t is measured in days. So I want to rewrite this in terms of a daily growth rate, and currently what we have is an hourly growth rate, because if I take 24 and multiply it by the number of days, that would get me the number of hours, because there's 24 hours in a day, right? If t was equal to, let's say 2, for example, that would be 48, which would represent the number of hours over 2 days. So if I want just the daily growth rate, and t represents the number of days, all we would do is we would rewrite this so that your exponent is just the number of days by itself. Just a t by itself. But again, we want to keep this equivalent to what we started with, so I'm going to raise the inside part to the 24th power, again such that if I multiply these exponents, I'd still end up at 24t, which is what we started with. So they didn't tell me what to round to again, so in this case I'll round to 3 decimal places. And since my exponent is the number of days, this number would show me my daily growth rate. So if I needed to pick that out, I'd say like 98.6% is how much I'm growing per day instead of looking at an hourly rate. The last scenario is something that looks like exercise 4. Again, where they've given us an equation already. It says the population of pigeons in a city is 150 and is growing exponentially at a rate of 10% per year, and they set up the function for us, again where t is in years. I want to write a function in terms of the weekly growth rate, where w represents weeks. So the only difference between this problem and exercise 2 is that instead of leaving the exponent as 52t, I'm going to make a substitution since they say to write it as w weeks. So again, p of t starts as this. And I want my exponent to represent the number of weeks. So since t is in years, 52 times the number of years would represent the number of weeks. But again, I'd have to raise the inside part to the 1/52nd power to make sure, again, that this is still t if I wanted to rewrite it to keep my functions equivalent. I'm going to round a little bit here, again, just to 3 decimal places. So 1.002 to the 52t. But in terms of what the instructions said, they want us to write a function in terms of the weekly growth rate where w represents weeks. Well, here's the great news about that. 52 times t already represents the number of weeks. So the only thing I have to do is, instead of writing a function of p of t, I'm going to write a function of p of w. And instead of 52t, which again is representing the number of weeks, I'm going to substitute that in with w, simply because they asked me to write an equation in terms of w. A lot of the times you'll have to know this for multiple choice questions where they change variables on you, but it's no different from a regular rewriting problem. We only make a substitution in for that exponent at the very end.